right, so last section we're going to look at this week is in chapter 3, and it's on dividing. Okay, so dividing things, factoring things, those kind of go together. So we're going to look at something called the factor theorem, and then we're going to practice doing some division. Now, somebody mentioned earlier you can use synthetic division sometimes, which is a faster way to do certain kinds of problems, but you can't use synthetic division on every kind of problem. So this is a problem that synthetic division would not work on. This is one that it would. Okay, but definitely won't get to that synthetic division today. We won't get to that. All right, so remember that the terms that we use, 0 or root, those are kind of interchangeable terms. And what does that mean? Like if I said, here's an equation. Let's just set it equal to 0. And if I said to you, -3 is a root, which it is. -3 is the root in that equation. What does that mean? Yeah?
It's a point on the x-axis where the line would cross.
Yep, it's where the line would cross on the x-axis. It would cross the x-axis at -3. And -3 is also the number that you can plug in for x and then get what for y? 0. Yeah. So it's the number you plug in for x and you end up getting 0 as the answer. So that's actually what I just said. So it's the solution to setting an equation equal to 0. That's how you find a root. With a linear equation, there's only one. With a quadratic, you can have up to how many roots? 2. Up to 2. Yeah. Okay. So what we're going to do is we're going to look at how can we use division to find roots. Right? How are those two things connected? That's what we're going to look at. And what I'm going to do first is kind of show you an example with just regular numbers. And then we'll do an example with letters. Okay. So let's say I want you to factor the number 12. Okay, I want you to factor that. To factor the number 12 means to take the number 12 and write it as something times something. Now I'm going to give you a hint at how to factor it. I'm going to tell you that 3 is a factor. That's one of them. What could you do if you know 3 is a factor to get the factor you don't know? And this idea is going to be the same whether we're going to do it with numbers or we do it with letters. It's the same idea. Yep.
Divide it?
Yeah, what would you divide?
12 divided by 3.
Right. Okay. You're trying to factor something and you know one of the factors. You can take what you're trying to factor, divide it by the one that you know, and that'll give you the one you don't know. That's how you do it. Yeah.
With my calculator, I noticed that the screen is slightly off.
The screen is off?
Well, it's like tilted to one side slightly.
It's like tilted? Wait, let me just take a quick look. All right. So here's the idea of how you figure out how to factor 12. I told you 3 is a factor. That means 3 times something would give you 12. The goal, whether we do it with numbers or letters, is to solve for the something. In this case, divide both sides by 3. 12 divided by 3 gives you 4. There's the other factor. And you figured it out by dividing. 12 divided by 3. But the key is you have to know one of the factors to be able to divide and get the one you don't know. Now, the other thing is, notice here, I said to you 3 is a factor. I want you to think in terms of like a remainder. 3 is a factor. If I divide 3 into 12, what do I get for a remainder? So 4 is the quotient. What's the remainder when you divide 3 into 12? Yeah.
None.
None. There is no remainder. No remainder. What's another factor of 12 besides 3 and 4? Just give me a number. 2, right? If you divide 2 into 12, what's the remainder?
6.
That's
wait,
supposed to be none, right?
None. There's no remainder.
Oh, yeah, okay.
Now, 6 is another factor of 12. What's the remainder if you divide 6 into 12? What's that?
No remainder.
No remainder. So anytime you have a number that's a factor, when you divide it in, you're always going to get a remainder of what, do you think? 0. If something is a factor of something else, then when you divide it into it, you always get a remainder of 0. If you try to divide something into a number and it's not a factor, like let's say you take 12 and you try to divide by 7. What's the remainder when you divide 12 by 7? Yep, 5. Since when you divide this in, you get a remainder of 5. It's not a remainder of 0. That means 7 is not a factor of 12. Okay, so that's going to be a pretty important idea. The fact that if you divide something into something else and you get a remainder of 0, then you know it is a factor. If you don't get a remainder of 0, then it's not a factor. Any question on that idea? All right, so we did it with numbers. Now we're going to try the same thing. We'll do some letters. Actually, it's exactly what I just told you. If you divide two things and get a remainder of 0, then the bottom number is a factor of the top number.
Well, that means that almost every number has a factor. It's just the factor might not be a whole number. It would be like, takes 12 divided by 7. The answer would be 1.14285714. It is still a number to multiply to equal 12. It's just not a whole number.
So generally when they think of factors, when you're talking about numbers, they think of like integer factors. I don't know if they would consider decimals really like factors of a number. Yeah, they generally restrict factors to being integers when you're talking about numbers. So why do we care if something is a factor of something else? Well, factoring makes it easy to find the roots. Okay? So if I gave you something like this and said to solve it, well, it might not be obvious what the answer is right away. But if you write it like this, if you factor it, and that is correctly factored, then you can easily see what value would make the first factor 0, and then what value you could plug in for x to make the second factor 0. So -1, -2. So factoring makes it a lot easier to find the roots in a problem. That's why we usually do it. So that process that I just showed you guys, taking 12 and dividing by 3 to figure out the factor we didn't know, you can do the same thing with a polynomial. Like if I told you, let's say you didn't know how to factor x squared plus 3x plus 2. But I told you that it's something times something. And I told you one of the factors is x plus 1. What could you do to figure out the one you don't know? Just like we did with the 12 and the 3. Yeah.
Divide x squared plus 3x plus 2 by x plus 1.
Yeah. If you divide each side by x plus 1, you'll get the factor that you're missing. And that's what I'm going to show you how to do right now. How to divide it when it's a polynomial and not necessarily a number. So I think what I'll do is I'll maybe I'll put the steps on the board and we'll kind of do a problem at the same time so you can see what the step is and then we'll apply it to that problem. So I think there's going to be 5 steps. So you might want to leave, like, if you're not going to do it side by side, you might want to leave 5 blank lines. And then put this example below that. Okay, so this is the process that you follow anytime you want to divide polynomials. All right, so the first thing is, just to make sure we understand what's what. The part on the inside is called the dividend. This is the dividend. And the part on the outside is called the divisor. And the first thing we have to make sure of is if the dividend, the part on the inside, is missing any terms, we need to fill in a spot for it, because we're going to have to line up like terms as we do this. We're going to get some squared terms, but there's no squared term in the dividend, so we need to make a spot for it. Since there's no squared term, we're going to fill in a 0, x to the second power for the one we're missing. And you have to fill in every term that you're missing. Okay, so if your highest exponent is a 3, then you need to see the exponent of 2, the exponent of 1, and then the constant. Okay, you don't do anything to the outside. Okay, so I've got the x cubed. So I'm going to put that one there. And what one am I missing next?
X squared.
I'm missing x squared, so I'm going to fill in 0x squared. Okay. Do I have the x term?
Yeah, it's negative 8x.
Yep. So we don't have to. We're not going to fill in a 0 because we have it. Do we have the constant? Yep. And Isaiah, what's that one? 3. Yep. Plus 3. Okay. Now we're ready to go. So that's the first. Fill in any terms you're missing in the dividend. Okay, the next step. You're going to take the first term of the divisor, which is this, x, and you're going to divide that into the first term of the dividend. So if you want to think kind of what you're doing off to the side, you're doing this. X cubed. And you're going to divide by x. Now remember the rule, if you don't remember, when you divide two things with the same base, you take the 3 and the 1, and what do you do with the two numbers?
Subtract.
You subtract them. Yep. So what is x cubed divided by x to the first?
X squared.
Yep, x squared. So you're going to put that. It doesn't matter where you put it. You just put it above the line somewhere. Okay, so x squared. All right, so that's our first step. Any question on the first step? Okay, the next step. Multiply the answer that you just got from, that should say step 2. So take the answer that you just got from step 2, x squared, and you're going to multiply it to each term in the divisor. So it's like you're going to distribute this back out. And here's where you have to line up like terms. All right. So let's start with x squared times x. Yeah.
X cubed.
X cubed. We're going to put that under the x cubed. Now we do x squared times negative 3. It's x squared times negative 3. Huh?
Negative 3x squared.
Negative 3x squared. And that's it for step 3. Multiply what you got back out to each term. Line things up in columns. Any question on step 3? Does anybody know what comes next?
I think that was
Divide, multiply. It's the same thing you would do with long division, like back in like 4th grade. Yeah.
You have to swap the signs with stuff that you divide by.
Yeah. Now we're gonna subtract, which is like swapping the signs. So take what you got in step 3, and we're gonna put a minus sign. We're gonna put parentheses around it. We're gonna subtract that whole thing. If you did the previous step correctly, something should cancel out. If nothing cancels, then you made a mistake. Right. So let's subtract these columns. What's x cubed minus x cubed?
0.
0. Sometimes you get 2 things that cancel at the same time, and when that happens, it speeds up the problem. That's not going to happen here. What's 0x squared minus 3x squared?
2x squared.
3x squared. Okay, so now we have 3x squared. So divide, multiply, subtract. Anybody know the last step? Yeah.
Like repeat.
Yeah, repeat it, and you have to.
Drop down the next term.
Yeah, you're gonna drop down the next term, bring down the next term, and repeat. So the next term is an negative 8x. Okay. When you started this, you were dividing into something with x cubed. Now you're dividing into something with x squared. Every time you do a round of this division, this exponent should be going down. Okay, it should go down. So it was a 3, now it's a 2. You're going to keep going until this exponent is less than that exponent, which isn't even written there. What is the exponent if it's not written? 1. It's a 1. So you have to keep going until that number is less than that number. And that's the last thing that I write down. So keep repeating that process, I guess, until one of 2 things happen. You either end up with a remainder of 0. If you get remainder 0, then you can stop. Or, if you don't have a remainder of 0, you are done when the degree there is smaller than the degree there. Okay, so right now our degree is a 2. The other one is a 1. We need to keep going. So we're going to repeat the process. Now, you're going to divide x into 3x squared. So if you want to think like off to the side, you're doing 3x squared divided by x now. So what's 3x squared divided by x? Yep. 3x. Now, multiply your answer back out. So it's like a distributive property. Christian, what's 3x times x?
3x squared.
3x squared. And Cam, what's 3x times negative 3?
Negative 9x.
Negative 9x. And now, what am I going to do with those columns? Subtract them. So I'm going to subtract them. And again, something should cancel. Let's see. What's 3x squared minus 3x squared?
0.
0. And what's negative 8x minus 9x?
X.
X.
Right, that's going to become negative 8x plus 9x. So it's like negative 8 plus 9. So that's 1x. Okay, what's the exponent on that x? That's a 1. The exponent over here is a 1. Is the exponent here smaller than the one here? No, it's equal. So we got to do it one more time. So what do I have to bring down?
The 3.
Bring down the 3. Okay. And now we're going to divide x into x. So you're doing
That's
x divided by x. What do you get? plus 1. Okay, and now distribute it back out. 1 times x gives me x. And 1 times negative 3. Negative 3. And what do we do with those columns? Subtract them. And now if you look quick, you might think, oh, I got a remainder of 0, but be careful. What's x minus x?
0.
So that is 0. But what's 3 minus minus 3? 6. And the 6 is my remainder. Okay? So there's a couple ways you can now write your final answer. We can write it as quotient and remainder. Okay. The quotient is x squared plus 3x plus 1. And the remainder is 6. Okay. That is one way you can write it. Now, the other way you can write it is kind of going back to doing it with numbers. And I'm going to show you that way. Okay?
I don't know if this is the way you're about to show us, but x squared plus 3x plus 1 and then 6 divided by x minus 3.
Plus 6 divided by x minus 3, yes. So what you can do is, let's say you had 12 divided by, let's do 7. What's the quotient when you divide 12 by 7?
7.
1. Right? It goes in one time. And what's the remainder? 5. So when you divide 12 by 7, the quotient is 1, and the remainder is 5. Now, one way you can write that answer is quotient plus remainder over the original denominator. Okay? Try it here. Quotient plus remainder over the original denominator. So the answer is 1 plus 5/7. Or in this case, it would be 1 and 5/7. You can apply that exact same idea, quotient plus remainder over denominator, to the problem we just did. Quotient is x squared plus 3x plus 1. What was the remainder? 6. And what was the original denominator?
X minus 3.
X minus 3. Both answers are correct. What's nice about the second one is if you type that in on y1, and then you type this original problem in on y2, if you did it right, they'll look the same. So you can check your answer that way. So you'd have to type in x cubed plus minus 8x plus 3 divided by x minus 3. Oh, I can just show you. So in parentheses, x cubed minus 8x, I don't need the 0x squared, plus 3, but the parentheses are very important. We need those. Divide by x minus 3. And now, that's the original problem. And now let's type in what we got for an answer. X squared plus 3x plus 1. I'm just going to be a little careful with parentheses here. Plus, we need 6 divided by x minus 3. So the way I would do that is I would do 6 divided by x minus 3. I just want to make sure that it does that first. I don't think I really need this parenthesis at the beginning. I thought I was going to. Let's get rid of that. That should work. So let's hit graph and see what happens. If they look the same, then I know I did the problem correct. Don't worry how it looks, that's fine. So there's the original. And here's my graph in red. And notice that the two graphs look exactly the same. They traced right over each other. Okay, now just because the graphs look identical, that doesn't actually prove anything. It's just, it's pretty likely because they look almost the same that my answer is right. And it's a pretty good bet that it's right. Right, so that's the only advantage of writing your answer the second way. But if they don't say in the problem how to write it, you can do it the first way, or you can do it the second way. In fact, I might just give you a problem that says divide these two, and just tell me the remainder when you do it. So maybe all I want to know is the 6. Now, because we got a remainder of 6, what does that mean about x minus 3? Think about what we said earlier. We just tried to divide x minus 3 into something, and we got a remainder of 6. What does that mean about it? Yep.
X is 9.
It doesn't tell us anything like numeric. It just tells us that this is not a factor. So if you were trying to factor x cubed minus 8x plus 3, x minus 3 is not the way to do it. That is not one of the factors. You don't just want to sit here and keep guessing. Okay, let me try x minus 2. Let me try x minus 5. There's a better way to figure out what is a factor. Okay, but we just showed that that one is not. Okay, a question on that one? Let's try another one. Now, this is one where they've already filled in the zeros for you. So they were missing the squared term, and you were missing the linear term. Most of the time on a test, I probably would not do that for you. Okay, you're going to have to fill in whatever you're missing. And it looks like this could be a longer problem, but we're actually going to get two things that cancel at the same time in one step. So it's going to kind of shorten this up pretty quick. Okay, so the first thing we have to do is take 2x to the 4th and divide it by 2x squared. Take the first term that's inside and divide it by the first term that's outside. Okay. What do you get if you do that? X squared? Yep, you get x squared. Now we got to take the x squared, and what do we do with it?
Multiply back in.
Yep, we're going to multiply it back out to each number on the outside. So let's do one at a time. What's x squared times 2x squared? 2x to the 4th. What's x squared times x?
X to the 3rd.
X to the 3rd. And what's x squared times 1? Just x squared. All right. And now, what do we do with those columns?
We strip.
What is it?
Subtract.
Yep, I'm going to subtract them. Lily Rose, what's 2x to the 4th minus 2x to the 4th? 0. So that's gone. Lance, what's negative x cubed minus x cubed?
Negative 2x cubed.
Yep. So we just got to be careful there. That is negative 2x cubed. And then what's 0x squared minus x squared?
Just x squared.
What is it?
Just x squared.
If it was 0x squared plus x squared, it would be x squared.
0.
Oh, so it's negative x squared.
Negative x squared. Okay. And what do I do now?
Bring down the 0x.
Bring down the 0x. That's my next term. Okay. Now we're going to divide negative 2x cubed by 2x squared. Take the first term on the outside and divide it into the first term on the inside. What's negative 2x cubed divided by 2x squared?
Negative x.
Yeah, negative x. Now let's distribute that back out and watch what happens. Negative x times 2x squared gives me
Negative 2x squared.
negative 2x squared. Negative x.
Negative 2x to the third.
Oh yeah, negative 2x to the third. Yeah. Yeah.
I
Thanks.
said you on that one. I said it wrong.
Yeah, that's all right. We got it. Thank you. What's negative x times positive x?
Negative x squared.
That's negative x squared. And then negative x times positive 1.
Plus x. Or 1x. Oh, wait. Minus 1x.
Negative times positive, that's a negative. Okay. And what do we do with those columns? So, yeah, you're going to subtract them. Raina, what's negative 2x cubed minus negative 2x cubed? 0. That's going to cancel out. Okay. The next one, Brady, what's negative x squared minus negative x squared?
0.
That's also 0. So we got two things that cancel. When that happens, that's great because it's going to shorten the problem. And then the last part, 0x minus x. What is it? It's x. What's the exponent on that x? 1. What was the original exponent on the outside?
2.
2. Is 1 smaller than 2?
Yes.
We're done. Okay, we can't go any further. You just bring down the 2, and now that's your remainder, x minus 2. So in this problem, quotient is x squared minus x, and the remainder is x minus 2.
Now, on the test or anything that you asked us to do, is there a problem if we write it the other way at all?
No, you can write it, as long as you know what the quotient and remainder are, you can write it either way.
Okay.
Because I might just ask you on the test, tell me the remainder in this problem. And I might just have a box for that. And I don't care about the quotient at all.
Okay. Because I'm just like, every single time I write it, I just go straight to putting in plus the remainder over.
Yeah. Plus the remainder
Yeah.
over the original divisor. The remainder was x minus 2. Oops. So you wrote it like this.
Yeah, I always go to that, so I didn't know if that was okay to just always write.
Yeah, if it doesn't say, you can write it either way. But if I specifically set it up on the test where there's like a empty box,
like that.
then you have to type what goes in each box.
Okay.
So again, what's on the outside is not a factor of what's on the inside because I didn't get a remainder of 0.
I have a question. Why do we only put the zeros in front of the x's that are positive and they have no number before it? Because isn't that an implied 1? Why are we switching that to 0?
These two zeros?
Yeah.
Because they were missing completely.
They were missing.
Yeah, they weren't there at all.
Isn't there an implied 1 like there's an implied 1 in negative x cubed?
No. The original problem would have been this. 2x to the 4th minus x cubed minus 2.
Oh.
So I filled in the missing zeros for you in this one.
Okay.
But yeah, those two would have been completely gone from the original problem. Yeah.
So do you not count those when subtracting?
When subtracting?
Yeah.
Well, we did count. We brought it down and we used it. So 0x minus x. So we do use it. And then right here, 0x squared minus x squared gave us negative x squared.
There it is. The government announced it.
Yeah, I just doing the test. So yeah, we use the zeros. We have to fill them in because you got to make sure you have like terms in columns. And if you don't put the zeros in, then you won't have a column for the x squareds or for the x's in this case too.
Well, it's too late for them. I was went off first. They already perished.
You guys missed it. All right. So any other questions on that one? Okay. So
They really did over there.
all right. So this is basically saying that there is another way to write the answer, which I've already shown you. So I'm not really going to go through that idea again. All right. So if you want to write your answer in that other way, instead of doing like the Q and the R separate, that's what I just showed you. Now, let's say that all I want to know is a remainder when you do a problem. Just the remainder. I don't want to know anything else. Depending on how complicated your problem is, there is a quick way to find the remainder when you're doing a problem. Let me go back to the first one we did. This theorem would not work on this problem, but it would work on this one. Let's take the number after the minus sign. And let's fill it in for x here and see what happens. Okay, I'm going to just do it off to the side, and then we'll do a formal one. So let's plug 3 in for x. You'd have 3 cubed minus 8 times 3 plus 3. Okay, let's do this out. What's 3 cubed?
27.
27. What's 8 times 3?
24.
24 plus 3. What's 27 minus 24? 3 plus the other 3. 6. And look at what the remainder was when we did this problem. 6. So if you want to find the quotient, well, then you have to go through and do everything. There's no quick way to do that. But if all you're interested in is the remainder, there is a quick way to find it, as long as what you're dividing by is pretty simple. And by simple, I mean it has to be something like this. It could be x minus a number, or it could be x plus a number. If you're dividing by something more complicated, then this theorem doesn't work. You've got to do the whole problem out to get the remainder. All right, so that's called the remainder theorem. When you have a polynomial and you divide it by x minus c, could be x minus 3 like it was, x minus 2, x minus 8, but it's got to be x minus something. You can take the number that comes after the minus sign and fill that number in for the variable in the top, and that'll tell you the remainder. So like if I had 8x squared plus 3x plus 6, and I wanted to divide by x minus 2, if you want to know what the remainder is, just take the 2 and fill it in the top for x, and that'll tell you the remainder. I'm not going to do that one, but we'll do another one. And knowing the remainder is very handy, because if you have a remainder that comes out to 0, what does that mean?
It's a factor.
It's a factor. So if you have a quick way to figure out if the remainder is 0, then you have a quick way to figure out if something is a factor. That's the point. All right, so you just take the number that comes after the minus sign, and like if I did this, it would be 2 squared is 4, times 8 is 32, plus 6 plus 6, it's definitely not 0. So x minus 2 is definitely not a factor of what's in the top. All right, let's try. So all I want to do in this problem is find the remainder, and we'll do 2 problems. The first one we're going to do is f of x, and we're going to divide by h of x. So f of x is in the top, h of x is in the bottom. First of all, is what's in the bottom the kind of thing that's supposed to be in the bottom to use the remainder theorem?
Yes.
Yes, it is. It's supposed to be x minus a number. Yep. do that one after. So let's start by figuring out the remainder when we do f of x divided by h of x. So f of x divided by h of x, and we're finding the remainder. So the theorem says, take the number that comes after the minus sign. You don't include the minus sign with it. It's just the number after the minus sign, and you plug that into the numerator. Okay. What's the number that's after the minus sign here? 3. We're going to take the 3, and we're going to fill it in for x, and that's the quick way to find the remainder. Okay. So it's going to be 3 cubed minus 2 times 3 squared plus 3 minus 5. So I just filled a 3 in for x. What's 3 cubed? 27. What's 3 squared? Times 2? Negative 18. Plus 3 minus 5. Okay. What's 27 minus 18?
9.
So that's 9 plus 3 minus 5. And then 9 plus 3? 12. And 12 minus 5? 7. Okay. So if you were to do out the entire long division problem, f of x divided by h of x, you would get a remainder of 7. Which, bless you, it quickly tells you that h of x is not a factor of f of x. All right? Now, let's do the same thing again, except change the denominator to x plus 1. Now, I want to use the remainder theorem. Does this look like what it's supposed to look like to use the remainder theorem?
Yes.
No, it's not a minus.
It's supposed to be a minus, but this is close enough that we can fix it and make it work. Instead of writing it as x plus 1, you have to write it as x minus, and then something has to go in that box. Whatever goes in that box is the number we're going to plug in. What could you put here?
-1.
-1, yes. So technically you can use the remainder theorem if it's x plus or x minus. If it's x plus, you just need to fix it so it's x minus. Okay? And then whatever comes after the minus sign is what you plug in. So what are we going to plug in this time? -1.
So if it's x plus, you just take and do it x minus minus. If it's like a,
Right.
So like if it's x plus 3, it'd just be x minus -3.
Yes.
Alright.
And it would be -3 that you're plugging into the top. Okay, so the remainder this time, we've got -1 cubed minus 2 times -1 squared minus 1 minus 5. Okay, what's -1 cubed? What is it? -1, yep. And -1 squared?
1.
1 times -2.
-2.
Okay. What's -1 minus 2?
-3.
Okay. And -3 minus 1?
-4.
And then -4 minus 5.
-9.
So we just showed again that whatever we just divided by was not a factor because we didn't get a remainder of 0. Okay, so any question on that remainder theorem? Wouldn't work on this problem. This isn't even close to x minus a number. So if you want the remainder, you got to do the whole thing. Maybe there's some kind of theorem you could, figure out. It's not this. Okay. All right. Hold on. I think we're gonna. All right. Let's just try this. Don't worry. I don't have to explain that. So let's use, and let's just say the remainder theorem. If you see directions in the book that say factor theorem, just think it's the same thing for our purpose as remainder theorem. Okay. So use the remainder theorem to show that this is a factor of this. Now, one way I could do it is I could do out the long division. That's going to take a while. So the quick way is just to show that when I divide x plus 2 into what's below it, I get a remainder of what?
0.
Yeah, let's just show what the remainder is. So we're going to do x cubed plus 5x squared plus 5x minus 2. We're not really going to do this whole thing out. All we're going to do is the remainder. Okay, so first thing, is the bottom set up exactly the way it should be to use the remainder theorem? No. Is it close enough that we can fix it?
Yeah.
Yeah, this is close enough. It's got to be x minus something. What would you put in that box?
-2.
-2. Now, what number does that mean we're going to plug in for x in the top? -2. Yep. And remember, we're hoping we get 0 as a remainder this time. So we're going to have -2 cubed, 5 times -2 squared, plus 5 times -2 minus 2. Okay. What's -2 cubed?
-8.
-8. What's -2 squared? 4 times 5.
20.
So it's 20. What's 5 times -2?
-10.
-10. Okay. What's -8 plus 20? That's 12. And now what's 12 minus 10? 2. And 2 minus 2? 0. So we just showed that if you divide these two things, you're going to get a remainder of 0. What does that mean about x plus 2?
That's a factor.
It's a factor. So if you were going to try to factor x cubed plus 5x squared plus 5x minus 2, one of the factors is x plus 2. How would you get the other one? And this was the very first thing.
Oh, yeah, just divide on both sides by x plus 2.
Right, we'd have to actually do the whole long division out. If you divide each side by x plus 2, it will tell you what the other factor is. Yep. Just like when I said 12, 3 is a factor, you divide to get the other. Okay. So any question on how to use the remainder? It may say factor theorem. Just ignore factor theorem in the notes or in the homework page. Just do it exactly the way I just showed. Any question on that? Okay. Yeah. Yeah. All right. So we got 2 slides left. I think what we'll do, because we got time tomorrow, we'll stop here. And then we'll do the last 2 things, which they're very quick. Might take about 10 minutes. And then after that, you'll have the rest of the time to work on the review for the test. Yeah.
Does that mean we'll have homework tomorrow?
I'm gonna give you the review worksheet as homework, so you'll have some questions on the review worksheet, but it won't be separate from what I was already gonna give you. If you finish the review worksheet in class, you might not have homework. I'm guessing you'll have about 40 minutes in class to work on it. Okay, so that, let me just see, I might have to just change the last, is that you? Okay. The last couple. All right, so 1, 2, just doing the long division. Okay, there is on number 9, the directions say use the factor theorem to determine if something is a factor. Again, just do the remainder theorem the way I showed you. Let's skip 25 and 32. And some of the problems say use a graphing calculator to find the roots. Do people remember where that is? If you have to calculate a root?
Second
count.
Right. So actually, let's say I want the root of this one. Second calc 0. Pick a point that's to the left. Pick a point to the right. Do your guess. And it says the root is at -3.
How did you plug in the whole entire equation again? Because I did it.